So this was a weekly pop quiz, MCQs Pop Quiz 12. You can ask your doubts if you have in question 1. If any doubt in question 1. Question 2. Question 3. Any doubt? Question 3. Okay. For those who just joined now, this is MCQs Pop Quiz 12 and you can mention your doubts. So for question 3, in which equilibrium will increase in pressure at a constant temperature increases the yield? Remember, whenever we increase the pressure, the equilibrium will shift towards side of less moles. So increase in pressure will shift towards side of a less moles of a gas. If we check how many moles of a gas, 0 here, and how many moles of a gas, 1. So if we increase the pressure, the equilibrium will shift towards the left-hand side. When we check for this one, 4 plus 1, there are 5 moles of the gas on the reactant side, and there are 4 moles of the gas in the product side. So when we increase the pressure, equilibrium will shift towards side of the less mole. So in this case, it will also shift towards the right-hand side. What about option C? We have 2 moles of the reactant and we have the 2 moles of the product. So we have equal number of moles of reactant and product, the gaseous mole. So these type of reactions, the equilibrium is not affected by changing the pressure. Here when we check, we have 4 moles of the gas. We always check for a gaseous and we have 4 moles of a gas. So we have equal number of moles of the gas in the reactant and the product. That's why increasing or decreasing a pressure will not affect the position of equilibrium. Is it clear? For those who just joined now, this is the MCQ Pop Quiz 12. So today's session, I'll discuss the MCQ Pop Quiz, and the next session, I'll discuss the structure Pop Quiz. And the class format, like as we done the course once. So the first, like I will explain the topics, one topic from the beginning of the syllabus and one topic from organic chemistry, as it is having a greater weightage. Question 4 or 5, any doubt? Question 4 or 5? Any doubt? Question 6. Okay. In question 6, we have L, M, and N are 3 different elements in period 3. So they all belongs to the same period. L is the element whose atom is having 3 unpaired electron. So if there are 3 unpaired electron, what will be the group? Like example, P3 is there. So if, and it's a period 3, so that's why I wrote 3P3, because they already mentioned it's in third period. So if it is 3P3, then definitely there will, before that it will be 3S2. So which group this element belongs to? What this given indication? This given indication that this element belongs to group 5, because the group 5 elements, they always have p3 electrons, like 3 electrons in the p orbital. M is the element with the highest electrical conductivity. So if you recall the electrical conductivity, like when we move across the period, we have group 1, we have group 2, we have group 3, which are metals. And then we have a group 4, which is a giant macromolecular structure. So for metals, as we move across the period, electrical conductivity increases. And they mention M is an element with the highest electrical conductivity. M is the element which is the highest electrical conductivity. So which metal will have the highest electrical conductivity? So group 3 metal will have the highest electrical conductivity. That gives an idea that this should be a group 3 element. N is an element with the highest melting point in the period. So the melting point, what happened to the melting point? It increases till group 4, and then we have a simple molecular structure, it decreases. So the highest melting point is for the group 4 element. So this give an indication that this is a group 4 element. So how these elements are arranged, like example, we'll have group 3, 4, and 5. So group 3, M is a group 3 element, N is a group 4 element, and L is a group 5 element. Which statement about the element L is correct? So this is the positions in the periodic table according to their properties, given properties. So when we check the options, which one matches with the description? So L has a, and when we move across the period, atomic number also increases. L has a higher atomic number than M and lower atomic number than N. No, L has the highest atomic number compared to M and N. L is lower atomic number, so this is totally wrong. L has a lower atomic number, this is wrong. L has a higher atomic number than both M and N. So D should be the right answer for this. Is it clear? Question 6 related to the pop quiz. 12. So whenever, like, if it was P4, it means that it is a group 6 element. If it is P5, like P5 electron in the p orbital, it means that it is a group 7 element. If it is 6 electron in the p orbital, it's a group 8 element. Question 7. Sodium, magnesium, aluminium, silicon, phosphorus are all elements in period 3 of a periodic table. Which the three statements about the oxide and the chloride of these elements are given. So about these oxides and chloride, as we did about the periodicity, you have to learn certain properties for these chlorides as well as their oxides. So when we check the options, the ionically bonded oxides all react with a hydrochloric acid. This is true because the ionically bonded oxide is actually the metal oxides. When metal combined with oxygen, it will form a metal oxide, and metal oxides, they will have ionic bond between them. And they will all react with a hydrochloric acid. So this statement is true. So any option with a statement 1 is correct. So D is not an answer. It means either A, B, or C will be the right answer. All metal chlorides produce a neutral solution when added to water. So what about this statement? When we check the second statement, when we add this, like example, different, it's not like all the metal will produce a neutral solution. Some are even not producing this solution. Like example, if you see, so this is a table which you have to learn about. As you can see there, oxide, the chlorides. So sodium and magnesium chloride, the structure is ionic. When it dissolves, it will make a pH 7. But when it dissolves, it will form a weak acidic solution. And when aluminium is there, it is forming also acidic solution. So in the question, what is given to us? So this table you have to learn. In the question, what is given to us? All metal chlorides produce a neutral solution when added to water. So that statement is wrong. So any statement 1 was correct and any option with the statement 2 is wrong. So what we are left with? We are left with only C. And the two most electronegative element both form covalent bonded chlorides. Like example, if a fluorine is combined with chlorine or if oxygen is combined with chlorine, they will form a covalent bond, not an ionic bond. Is it clear? Question 7. So it is related to memorizing this table about their chlorides, oxides. Question 8, any doubt? 8 or 9? Question 8, question 9, any doubt? Question 10. Question 11. 9 as well. Okay. In question 9, a solution of a P and Q each contain different group 2 ions of the same concentration. So one of them is containing a magnesium ion, one contain a magnesium ion, another contain a barium ion. When we add sodium sulfate, when we add a sodium sulfate, because when sodium sulfate react with magnesium, it will form magnesium sulfate. Most sulfates are soluble except barium, calcium, and lead. So barium sulfate, when sodium sulfate is added, it will form barium sulfate and magnesium sulfate will be there. But because the barium sulfate is insoluble salt, so as a result, more precipitate will be there in case of a barium, because the barium sulfate is insoluble. Insoluble means greater amount of precipitate will be formed. So greater amount of precipitate or more precipitate will form with a barium. So either A can be an answer or B. When we add a sodium hydroxide, so when we add a sodium hydroxide, what will happen? It will form barium hydroxide or magnesium hydroxide. And when we compare the solubility of the hydroxides, the solubility of a hydroxide increases as we go down the group. Like the hydroxides become more soluble as at the bottom of a group. So at the top of a group, we have magnesium, and at the bottom of a group, we have barium. So which hydroxide will be more soluble? Barium hydroxide will be more soluble as compared to magnesium. Magnesium will be less soluble. So as we go down the group, the hydroxide solubility increases, become more soluble or dissociate into ion. So which will produce more precipitate because it will be less soluble. So magnesium will produce more precipitate with a hydroxide. So B should be the right answer. Is it clear? Question 8, compare the calcium and a barium, calcium carbonate and a barium reactivity with water. So what happened to the reactivity as we go down the group? We have a calcium and a barium. As we go down the group, the reactivity increases. Like the element become more reactive down the group. So which one we expect to be more reactive? We expect that the barium should be more reactive. So any option with a barium more reactive will be the right answer. So barium more reactive. And then thermal stability. Thermal stability, it become more thermally stable as we go down the group. What is the reason why the thermal stability increases? Because the thermal stability related to distortion. As a calcium ion is a smaller in size as compared to a barium ion. So when we have a carbonate ion, the same size of a carbonate will be same for both cases. So when we have a carbonate ion, because calcium is having a smaller size, so it will cause more distortion to the carbonate ion and it reduces the stability. It can decompose. But barium is larger in size, so it causes less distortion to the carbonate ion. So the carbonate ion is more stable or it will not break down at a low temperature. So as we go down the group, what will happen to thermal stability? It increases. And as we go down the group, what will happen to reactivity? The reactivity will also increases. So which one we expect to be more stable? We expect barium carbonate to be more stable. And which one we expect to be more reactive? We expect barium to be more reactive. That's why A will be the right answer for this. Next, question 10. J dissolve in water to give a solution K. So we have a solution K when J is dissolved in water. K gives a dense white precipitate when a silver nitrate is added. So silver nitrate is actually a test for the halide. It is chloride, bromide, iodide. So this give an idea, it might be chloride, it might be bromide, or maybe iodide. So either this could be an answer. It cannot be sulfate because it will be barium nitrate, will be barium nitrate or barium chloride should be added if it give a white precipitate. Then when heated with potassium hydroxide, whenever this is also a test for the ammonium salt, whenever we have the ammonium salts are there and we add an alkali like sodium hydroxide or a potassium hydroxide, so what it will form on heating, it will decompose to form ammonia gas. So here when a potassium hydroxide is added, K gives off a gas which turned moist universal indicator blue. Yeah, so it is giving a white precipitate here. So it confirmed that it is chloride. When it give a precipitate, it means that whenever a precipitate are given off with a silver nitrate, it means it is a halide, but it's a white precipitate. So this confirm it's a chloride. And options we have only chloride. But then when we add an alkali and a gas, ammonia gas is given off. So this give an idea or indication that there's an ammonium ion present. So there's ammonium ion and there's a chloride ion. So what should be the salt? The salt should be ammonium chloride. Because ammonium salt, when alkali is added, it will give off ammonia gas. Question 11, any doubt? Question 12. Question 12, part B. Okay. In calculation, the specific heat capacity of a liquid is taken to be 4.18 joules per gram per degree centigrade rather than 3.85. The use of 4.81 in the calculation. Look, if we are using a higher value of a specific heat capacity, so E is equals to Cm delta T. And if you see the result, what we calculated minus 185, but the data booklet value is 217. So our value is smaller, data booklet value is higher. So now if we we are using a formula E is equals to Cm delta T. And if we substitute the specific heat to be 4.2 or 4.18 instead of 3.85. So if we use a higher value of a specific heat capacity, what we will get? We'll get a greater energy or enthalpy change. So the enthalpy change or the energy will be higher. And if the enthalpy change or the energy is higher, the difference between our value and the data booklet value, that difference will decrease. Because if we use a higher value of a specific heat capacity, it means we'll get a higher value of E. If we have a higher value of E, we will have a greater enthalpy change. And as a result, the difference between the standard value and our value, the calculated value, will decrease. So the question is, in this calculation, the specific heat capacity of a liquid is taken to be 4.18 rather than 3.85. The use of 4.18 in the calculation, what it will do? How the difference will decrease, because let's say we got a value of minus 185. But when we are calculating the enthalpy change by using a formula, E is equals to Cm delta T. So if we are using a higher value of a specific heat capacity, we'll get a higher enthalpy change. If we use 3.85, if a smaller value of a C is used, then the enthalpy change will be smaller. We'll not get minus 185, we might get 160. Because if the specific heat capacity used is smaller, then enthalpy change will also be smaller. If enthalpy change is smaller, like our value was minus 185 and the data booklet value is 217. So if I use a smaller value of a C, I will get like minus 160. So you can see the difference between the standard value and our calculated value will be higher if we use a smaller specific heat capacity. But if we are using a higher specific heat capacity, as a result, this value will increase. So the difference between the final value or the percentage error will decrease. So it will lower the error in the final value obtained. The true value is not changing. The true value is not changing in the question. The value which is changing is our calculated value. The data booklet value is a standard, but this value which we calculated by using a formula that E is equals to Cm delta T. If we are using, like the example 3.85, the value for the specific heat capacity, we might get a minus 160 answer. But if we are using a value of 4.18, we are getting a higher value, minus 185 or minus 190. So the question is why 4.18 is used, why not 3.85? So what will happen? It will reduce the error, the difference between the data booklet value and our calculated value. And as a result, it will reduce the percentage error as well. Is it clear now? So the question is not about the standard value. The question is about the calculated value, which we are calculating. Question 13, any doubt? In question 13, enthalpy change of for the two reactions are shown. Enthalpy change of a reaction. Here, actually, what is this enthalpy change? This is a formation of iron 3 oxide, and this is a formation of a carbon monoxide. So the formation is given for iron 3 oxide and a carbon monoxide. What is the enthalpy change of this reaction? This reaction enthalpy change is unknown. Let's say X. So we know the formation. If iron reacted with oxygen, it will form iron oxide because it is iron 3 oxide. What is the formation of this one? The formation of this one is minus 824. And 1 mole is formed, so we kept it minus 824. Then if carbon react with oxygen and form carbon monoxide, the enthalpy change is minus 111. But because 3 moles of a carbon monoxide is formed, so this will be minus 111 times 3. So when we apply the Hess law cycle, where the two arrows are pointing out, that is the start of the cycle. Where the two arrows are pointing in, that is the end of the cycle. So the overall energy change is independent of the route or the path we follow. If we follow route 1 or we follow route 2, we get the same energy change. So it will be minus 824 plus X will be equals to minus 111. Sorry, I was disconnected. I'll repeat. As you can see, this is a formation of iron 3 oxide, and this is a formation of a carbon monoxide. So what we did, we add iron here and half oxygen, 1 whole number 1 by 2 oxygen. So when it will react, it will form iron 3 oxide. That is because 1 mole is formed here. So that is why minus 200 and minus 824. Here, if the carbon is also involved, so it is forming 3 moles of the carbon monoxide. If it is forming 3 moles of a carbon monoxide, so it will be minus 111 times 3. Because to form 1 mole, it is minus 111. But to form 3 moles, it will be minus 111 times 3. We want the energy change for this reaction. Where the two arrows are pointing out, that is our start of the cycle, and two arrows are pointing in, that is the end of the cycle. So if we follow route 1 or we follow route 2, the overall energy change is independent of the route or the path we follow. So minus 824 plus X is equals to minus 111 times 3. So if we need X, so it will be minus 333 and plus 824. What's the answer for this? Minus 333 plus 824. So that is equals to 491 positive. So A will be the right answer. Question 14, any doubt? In question 14, which of the following alkane would be expected to have the highest boiling point? The boiling point depends on what? It depends on the number of the carbon. Greater the number of the carbon, higher the boiling point. And it also depends on the branches. If we have more branches in the hydrocarbon, greater number of the branches, the boiling point will be lower. So first we count the number of carbon: 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. So the question is, which one we expect to have the highest boiling point? The boiling point depends on what? Number one, it depends on the number of the carbon. Number two, it depends on the number of branches. So which is, if we increase the number of the carbon, the boiling point will also increases. So which is having the highest number of carbon? So first priority is a number of the carbon. Second priority is a branch. So that's why, because D is having maximum number, like highest number of the carbon, so D will have the highest boiling point. Then if there was another group which was having 7 carbon atoms, and then if it was having less branches, then we'll select that one. Is it clear, this one? So the boiling point depends on the number of the carbon first, and then so boiling point depends on the number of the carbon and inversely proportion to number of the branches. Higher the number of branches, lower the boiling point. Question 15 and 16, any doubt? Question 15, 16. So in question 15, the boiling point of a hexane is 69, whereas cyclohexane is 81. The main reason for a cyclohexane, a higher boiling point, is that, so first, what is the formula for hexane? Hex means 6. So C6, and it's an alkane. So the number of hydrogen are twice plus 2. So 6 multiplied by 2, 12 plus 2 makes 14. But a cyclic alkanes have a same molecular formula as alkanes. So if the number of carbon are 6, the number of hydrogen will be 12. Now, when we check the options, what kind of intermolecular force they have? If we check the first option, so according to first option, it has more electron. That is wrong. Why? It has less electron. As you can clearly see, the cyclohexane has less number of atoms as compared to hexane. So it has not more electron, it has less electron. They have a stronger permanent dipole. They don't have permanent dipoles because both are non-polar compound. Non-polar compounds have as a result, what will happen? The non-polar compound does not have permanent dipole. The non-polar compounds have dipole-induced dipole forces or the London dispersion forces. Have a large surface area in contact. How non-polar? All alkanes are non-polar. They don't have the poles because the difference in the electronegativity between the hydrogen and the carbon is negligible. Very small difference in electronegativity, so all alkanes are non-polar. That's why the alkanes are volatile liquid or gases at room temperature. Form hydrogen bond, that is also wrong because it does not have, hydrogen is not attached with oxygen, oxygen, nitrogen or a fluorine. So they cannot form a hydrogen bond. So what we are left with, they have a large surface area in contact because the boiling point also depends on another factor which is called a surface area. If two molecules have a large surface area in contact, as a result, it will have a higher boiling point as well. So surface area, the number of the carbon, the number of the branches, the type of intermolecular force, they all affect the surface area in contact. As you can see, 6 hydrogens are there. This is a cyclic alkane. And another cyclic alkane, the ring is above it. So as a result, when these molecules will interact, they will have a large surface area in contact with each other. That is why the boiling point is higher. So the boiling point is depending on the surface area, the number of the carbon, the number of branches as well. So not more electron, because that is wrong. They don't have a permanent dipole. They don't have hydrogen bond. So they have a large surface area in contact that result in a higher boiling point. The structure and the boiling temperature of a butane and propanol are shown. So butane and propanol are there. The main reason the propanol has a higher boiling point than than butane. As you can see, butane, it will be a non-polar molecule, and this will be between oxygen and a carbon. There's a difference in electronegativity. So this will be partial negative. This will be partial positive. The number of electron, when you check the number of electron depends on, like, this carbon, each carbon contain. So as you can see, so when we count 1, 2, 3, 4 carbon are there, and how many hydrogen are there? The hydrogen are 10. How many 1, 2, 3 carbon are there? How many hydrogen? 6 hydrogen and oxygen. So when we count the number of electrons in the carbon is having 6 electrons, so 6 multiplied by 4 makes 24. And hydrogen is having 1 electron, so 1 multiplied by 10, so that will be 10. So total it will have 34 electrons. What about this one? Carbon is 6 multiplied by 3 makes 18, and hydrogen 1 multiplied by 6, so 6, and oxygen is 8. So when we count the number of electrons, so this will be 32. So as you can clearly see, the question is why propanol is having a high boiling point. It also depends on number of electron, but this is not the case here, as the propanol is having less number of electrons, so A is not the right option. When we check the second option, propanol, as you can see, it has a permanent dipole, but this is an alkane, does not have a permanent dipole. So propanol is having a stronger permanent dipole, that's why it will have a high boiling point. The large surface area, as you can see the structure about the surface area, this is a surface area of one, and this is a surface area of another. So both have the same surface areas in terms of the structure. And the hydrogen bond, how number of electron affect the boiling point, higher the number of electron, greater the number of electron, higher the boiling point it will be. So number of electron increases, the boiling point should also increase. But it's not like only one of the factor affect the boiling point. It is the number of electron, it is the number of atoms, it is the surface area, type of intermolecular forces, number of the branches, or that all collectively affect the boiling point. So it's not the one parameter that affects the boiling point. And it does not have a hydrogen bond. Why it does not have a hydrogen bond? Because a hydrogen bond, hydrogen should be attached either with nitrogen, oxygen, or fluorine. Any one of these most electronegative element to have a hydrogen bond. Question 17, any doubt? 17, 18, 19, 20. In question 17, hydrogen bonds are formed when methanol dissolve in water. Which structure best represent the hydrogen bond? So hydrogen bond is, as we know that when hydrogen is attracted towards the most electronegative element, like bonded, and in a hydrogen bond, what actually happen? The bond angle is always 180 degrees. That is one thing. And the hydrogen is attracted towards the lone pair on the other molecule. So this is a hydrogen bond, that is correct, and the bond angle is 180, so this is right. But what about B? B is the hydrogen bond is correct, but the bond angle is not 180. Like this bond angle should be 180, but this does not look 180, so that's why this is wrong. B. What about option C? Option C, this hydrogen cannot form because this hydrogen belongs to a molecule of a methanol. So this hydrogen cannot form a hydrogen bond. Why? Because this hydrogen is not attached with oxygen or nitrogen or fluorine. So that's why this hydrogen bond is shown wrong, incorrect. Same way, why this is wrong again? Because the hydrogen, which is hydrogen in a molecule, should be attached directly to oxygen, nitrogen, or a fluorine, and then it will be attracted towards the lone pair of another molecule. But the problem here, this hydrogen is attached with a carbon, it's not attached with any more electronegative element. That's why this hydrogen bond is shown incorrect. So A and B, hydrogen bond is shown correct, but the bond angle, whenever there's a hydrogen bond, it must be 180 degrees. Question 8.